friends, this is Tanvi from Radiance Academy. Today I'm going to tell you about the atomic structure and the subatomic particles. So, what is an atom? Basic unit of an element. I've answered it. But then you'll ask me, what do you mean by this? So, let's consider your house as an element and the rooms in it the atoms. Thus the rooms being the basic unit of your house, the atoms are the basic unit of the element. Got it? Good. Subatomic particles, which means the parts of an atom. We have in an atom three subatomic particles: the protons, neutrons, and electrons. The protons and neutrons form the nucleus, and the electrons revolve in the orbits present around the nucleus. Just remember, the protons and neutrons are best friends, always together, and electrons just roaming around the two best friends. Here you can see how the subatomic particles are arranged. The protons and neutrons in the nucleus and the electrons revolving around them. Can you compare this to the solar system? Let's see. Isn't it exactly the same? We can thus consider the sun as the nucleus, which contains the protons and the neutrons, and the planets as the electrons revolving around the sun. So you can compare the structure of an atom and the solar system. Let's learn something more about these subatomic particles. The protons have a positive charge and an unit mass. The neutrons have no charge at all, so we call them neutral neutrons. And they also have an unit mass like their best friend protons. The electrons have a negative charge and a negligible mass. So let's move on now. Atomic number. So now you know a little about an atom. Let's learn something more, which is the atomic number. Let me try to explain this in the language of mathematics. If x is equal to y and z is also equal to y, then x is equal to z, right? Thus, the atomic number is equal to the number of protons, and the number of protons are equal to the number of electrons. We can also say that the atomic number is also equal to the number of electrons. Got it? We have another number here, the mass number. The mass number is equal to the sum of the number of protons and the number of neutrons. You can also call it the best friend's number. I'm sure you can guess what this is. That's right, the periodic table. When you see the periodic table, you see a lot of numbers present around the symbols of the element. Now you know what they are: the atomic number and the mass number. So this is how the atomic number and the mass number is represented. You all measure your weights, right? The atoms do it too. So the atomic weight and the molecular weight is determined by comparing it to the mass of an atom of hydrogen, or 1/12 the mass of an atom of carbon. Orbits or shells are imaginary paths in which the electrons revolve. In an atom, they are named as the K shell, L shell, M shell, N shell, and so on. The K shell being nearest to the nucleus. So you can see here, nearest to the nucleus is K shell, then is the L shell, M shell, and N shell. There is a limit for each shell to carry a certain number of electrons only. This maximum number is determined by using the formula 2n square. After 2 electrons, the K shell says, I'm full, I can take no more. L shell, a little larger than K, says I'm full after 8 electrons. M shell, a little more larger, says 18 are enough. N shell, a little more larger, O some more, P some more. This goes on till the number of electrons in the atom are over. This is how the shells or the orbits are arranged. Let's compare it to the solar system. The sun being the nucleus, the K shell, the orbit of Mercury, the L shell, the orbit of Venus, M shell of the Earth, N shell of Mars, and so on. If you want to know more about these cute little atoms, keep watching and don't forget to like and subscribe our channel. Thank you for watching.